So now we've literally already dived into the topic of work, and I think I brought the matching picture for that. And for a start, I would just like you to imagine you'd be this guy, and this would be your new work environment. So how would you feel about that? I think it's not the worst thought, maybe even now after a long day of Chi, having to write your next research paper in this situation. Probably feel relaxed, free, enjoying yourself, but maybe this is also not the perfect setting for working, and you feel a little bit disconnected and restricted in your working style and your working equipment. So with new technology, working like this is totally possible, and we see a trend that working is getting more flexible and more remote. But still we have to consider how we can support a good working experience and support the tasks that you actually have to work on. And then another big trend we're observing, and that's why I'm in this session, is of course that we have a change in our mobility and the use of our personal transportation means. And with the advance of self-driving cars like those, which are mainly concepts now, but then you also have the possibility to change the way that we experience driving, and, or more to say, the way we're being driven around in the future. And this also inspires new forms of interior and exterior design of future cars. So we combined these two trends in the study and investigated how we could support working in a self-driving car. And the study was carried out in our Fraunhofer lab in Stuttgart together with the car manufacturer Audi. And for the study, we employed a combination of subjective, behavioral, and neurophysiological measures to assess the working experience of different levels. So this research was really motivated and also conducted in the scope of the 25th Hour project of Audi, which is all about the question how we could use the extra time we gain when we don't have to drive ourselves anymore, but we are more or less driven around. And that's why they call it the 25th hour, the extra hour we gain. And they did quite some research on that and on different things we could do with our extra time. But in the work I present today, we only focus on the productive time. So the idea how we could be productive in a self-driving car. And our research question was, how do 3 different car interior configurations affect the passenger's concentration, effort, performance, and cognitive workload while working on concentration-demanding tasks? So for that, we had to design 3 different car interior configurations. And we decided to do that with a combination of visual stimulation, light, and sound in a prototypical car environment. So we did the whole study in a driving simulator and a concept car. I think what might be interesting and not that straightforward is the part with the visual stimulation, because I think light and sound manipulation in the car is quite easy to understand. But this visual stimulation was really based on a design proposition by Audi that in a car of the future where you would also want to work, you could have your car windows could be displays that you could use for your work. So similar as you see in this sketch there. So within this prototypical car that was constructed, we had 3 different configurations where we varied the visual input, the sound, and the lighting conditions. And the first one was what we call the normal configuration, which is pretty much what's like to be in a car right now. And then we had 2 variations, of which one was the laser-oriented configuration, which was really supposed to kind of mimic the experience of being in a living room, working in a living room, with some light that's more creating like a cozy atmosphere, a little bit more, fewer blue components of the light, with some sounds around you and also some visual input on these display windows, which could, for example, display some videos or incoming messages, something that you would do in your free time. And then we had the third configuration, which is the concentration focus configuration, where we lowered the visual stimulation by basically making the windows opaque. So you would really be like in a cocoon where you can focus, and we also adjusted the light accordingly and applied some nature sounds. And all these conditions were tested in the within-subject design, so we used a block design, and each participant were confronted with all the 3 conditions. And then we applied our 3 measurements. So for subjective experience, we used an adjusted version of the NASA task load questionnaire with 4 items, namely concentration, frustration, distraction, and mental effort. For performance, we measured the reaction time on the concentration task that I will explain in a bit. And as a neurophysiological measure, we used EEG recordings to track the brain activity during the whole study. So because this is a kind of very basic study, and we're also using EEG, we couldn't use such nice working tasks as in the previous talk. So we just started with some typical psychological go-no-go tasks where participants had to press a button to respond to certain visual or auditory stimuli. So we had a visual concentration task and an auditory concentration task. And for basically each of our experimental conditions, people had to complete 2 rounds of the visual concentration task and 2 of the auditory concentration task. And after each task, they had to fill out the questionnaire. And of course, the behavioral measures and EEG recordings were performed simultaneously. So to give you an impression what this actually looked like, I have a small video to show the whole setup in practice.
Audi built a lab exhibit that resembles a futuristic car interior, very clean, digital, networked. We wanted to know, how do digital signals, lightning, mood and audio stimuli in the automobile affect the human brain positively or negatively? For example, the stress level and the ability to concentrate. While wearing EEG caps to measure brain activity, test persons were confronted with stimuli which made it hard to concentrate on solving tasks. But then we filtered these virtual messages out. We also changed lighting to blue, which supports the ability to concentrate, turned the windows opaque, and altered the volume of noisy distractors like city chatter. The results proved that the human brain is calm in surroundings which are optimized for mindful use of time, but on the other hand is challenged when processing even small distractions while concentrating on a specific task.
So this is just to give you an impression of the simulator and the experimental setup. And in our study, we actually tested 30 participants, but I will only report the data of 23 participants because with EEG it's always difficult to get clear data, and some of the data was really noisy, so we had to exclude 7 participants. So what did we find? For the subjective experience and the visual concentration task, we found that for the concentration focus condition, the concentration effort, the frustration, and the distraction were significantly lower than for the leisure-oriented condition. This was not exactly reflected in the auditory task. There we only found significant differences for distraction, but then here we see that we have basically difference between all the conditions and not only the leisure-oriented and the concentration-focused condition. The normal condition was rating-wise always a little bit in the middle between the others, but we didn't find any significant effects for the visual task really. For the performance, we analyzed the reaction times for the two different tasks. And here also we see that there was a difference between the concentration focus condition and the other two, and that it was significantly lower for the visual task. And we also found a similar picture for the auditory task, where also the concentration focus condition was much lower. But again, here also we didn't really find any difference between the normal and the leisure-oriented conditions. So the analysis of the EEG data is a little bit more complicated, and I'm not going to explain it in detail. It's all in the paper. But just to sum it up a little bit, of course, we were looking at where we would find brain activity during the task. And we know from previous research that cognitive workload, the construct we were trying to measure here, is associated with changes in the theta band power in the frontal brain areas and the alpha band power in the parietal occipital brain areas. And if you take the ratio of that, you can calculate the so-called workload index, which others have done before. So that's the analysis we used here. And you can see for both tasks, auditory tasks this time on the left and visual tasks on the right, what the workload indices were. And here also we see differences between the concentration-focused condition depicted in green and the other two conditions. So the workload was significantly lower for the concentration-focused condition. But again, here no difference between the normal and the leisure-oriented conditions. So to sum that up, all our three measurements kind of point towards the same direction. We had a lower subjective concentration level and distraction level in the concentration focus condition. We had a higher performance, or people were faster reacting to the task in the concentration focus condition. And we also had a lower mental workload there. But I think what's also interesting to notice that we didn't really find difference between the normal and the leisure-oriented configuration, which indicates to some extent that maybe the brain is not as easily distracted as we might think. So of course, this is only a lab study, so the ecological validity is rather low. And to be truly able to design future interiors for cars, we would have to go out of the lab and gradually transfer that and apply it to real context of automated driving. So thanks for your attention, and I'm happy to talk with you about this research and answer your questions.
Hi, I'm Bjorn. I work at Uber as a UX researcher. This is really cool. Thanks for sharing. So your conditions varied a lot in terms of like the different types of stimulation and light and sound and other sort of distracting tasks and things like that. The quantitative data seems fairly clear, but I'm kind of curious like what the participants said about the different types of interiors and sort of what they hypothesize leads to different subjective experiences in them and things like that. Just kind of curious to untangle the
So you're curious about the qualitative data. Like we really focus on the quantitative data here. That was also a requirement from Audi because they really wanted to quantify it, as companies usually do. But yeah, I think the participants didn't really see much of a difference because the things. I mean, they said that this the visual stimulation in the leisure-oriented condition was. There was something there, but they were really focused on the task, so they didn't say they were distracted a lot or that it was really annoying. I think the only thing with these studies is that if you do all these three conditions and you use EEG and you have your preparation time before that, it's a really long study, so people get get tired anyways. So I think that's maybe also why they didn't really share any major differences between the conditions with us.
Hi, Shamsi Iqbal, Microsoft Research. So, great talk, thank you. So when we think of cars as future mobile offices, one of the things that comes to my mind is that it is a moving vehicle, so it's not quite like your regular office. Maybe I missed this, but can you talk a little bit about the effects of the road? So when they were driving, what was the road condition like?
Mm-hmm. Yeah, this is a good point, because in this study we also simulated a really slow drive. Because also, of course, in simulators you always get the problem with motion sickness, but also driving in general, some people, myself included, find it really hard to even read in the car. So I think this is something that will have to be solved in the future, and we deliberately made the drive rather slow so we wouldn't have these effects there. But it will be difficult, yeah.
Hi, Andreas Riener, Technische Hochschule Ingolstadt. I think you have already answered my question, a little bit at least. I think it's a cool setting for stationary use experiments, but when it comes to this concentration scenario, and you just have opaque windows, 360 degree more or less, and it comes to real driving setting, I would assume that this has high effects on the motion sickness. If you can't see anything, it's just blurred around. Have you thought about this, or is there any solution you might have already?
Yeah, I think this is a really good point. Also, I'm not sure if I myself would be comfortable driving in this car without seeing where it's going. So I think this configuration is really kind of the extreme of interior design variant we could have there. So it was kind of testing out how that would work and whether it would help people to concentrate more. But I'm not sure if this is really something that should be applied just like that in the future. I mean, we didn't have the problem with the motion sickness because the drive was really slow, so really nobody of the participants had any problems with that. But we also did the same thing as a kind of demo, and there it was a little bit different. So I'm not sure if the making all the windows opaque works, but I think what's an interesting thing to think about is that a car is a different space than an office. It's a restricted space, but you can also do different things there, and things that maybe even help you work better than in an ordinary office.
There's still room for questions.
Hi. I was wondering if you could tell me a little bit about the nature of the audio and visual tasks you used, and also, do you have any intent to look into automation trust as you move towards more ecologically valid research?
I only got the first question. The second one didn't really reach my ear.
Oh, sorry. Basically, in terms of future research, are you intending to look at automation trust and how that affects people's performance? I ask because we're about to start some research in prototype level 4 vehicles, and one of the things that we think might be a big issue is going to be trust, because that's going to inform how people are going to interact with something regardless of the actual capabilities.
Yeah, so for the first question about the tasks we use, there were really some basic psychological tasks, or tasks that are often used in psychological research, where you have to kind of react upon a certain stimulus. Let's say you could a little bit see it in the video. It was either a certain letter, to see whether a certain letter was present on the screen or not, and a certain sequence of letters, or a certain sound. And for the second question you had, we are not looking into that because, I mean, at least I'm not really focused on this car research. I'm a user experience researcher, so I'm trying to apply these methods to different setups, but still I think it would be a very interesting thing to investigate, because that was also what I was kind of aiming at when I said when you have the windows opaque, you can't see where you're going, And of course, it might be nice to be in this secluded space where you can actually work and stuff, but then you have to have a really high level of trust towards the car, and I'm not sure that people have that already, so I think that would be an interesting line of research to extend what we just did there.
Lots of opportunity for future work. Let's thank Kathrin again.